So with our knowledge about probe size contributions, let's look back at the reduced brightness and how this plays a role in the geometric probe size. So the probe size that we get from the magnification or demagnification of the microscope system. So recall that the reduced brightness was defined as the ratio between the current and the area and solid angle and potential of the beam. So practically we evaluate that by dividing an area, a solid angle, and the voltage. We've seen that we do this differentially, but practically we assume the current distribution to be homogeneous and we write it in this fashion. Now we need an expression for the solid angle. So in general the solid angle is given by 2 pi times 1 minus the cosine of the opening angle, so the in-plane opening angle of the beam, alpha. And we can use here the geometric expression that the cosine of alpha equals 1 minus 2 times sine of half alpha squared, which if we use our small angle approximation, sine alpha squared equals alpha squared, so in this case half alpha squared. So with that, this equation becomes 2 times pi 1 minus 1 minus 2 times half alpha squared, and then we have 3 brackets. So this is inserting this equation into the above equation. So if we write this out, this gives us for the solid angle omega equals pi alpha squared. So that is a very easy expression in case of electron microscopy, small angle beams. So we can define the reduced brightness in the source plane. So if we have our source here with a size given by the virtual source size, we have a beam with opening angle alpha here. So this is the alpha in the source plane. So we define the virtual source size by looking at the extractor plane and projecting all the rays back. So here we use the voltage in the source plane, and we get for the reduced brightness in the source plane that this is equal to the current, the area of the virtual source, so that is pi times the virtual source diameter divided by 2 squared, so pi r squared. It is the solid angle, the expression we just saw, so this is pi the alpha in the source plane, so this alpha here, squared times the voltage in the extractor plane. Now we can also look at the situation in the image plane. So here we have the image plane, we get a certain image probe size, so the probe size contribution, the geometric contribution to the probe size, and the beam comes in here with a half opening angle that is given as the object angle, so alpha image. So in this case the reduced brightness is equal to PR, the current in the probe, IP. So of course here this was the current that was extracted from the source, so the source current divided by pi times the image over 2 squared by alpha image squared times the voltage in the probe voltage. Now from this equation we can see that here we have the image source size, the opening angle, the current, and the brightness. So let's now look at what this looks like if we get an expression for the probe size. And so if we take the d image over 2 squared out, we see that this is equal to the probe current divided by the reduced brightness pi times the image opening angle squared times the voltage in the probe. Or in other words, so if we get to an expression for the image, we can rewrite this to read 2 over pi times the square root of the probe current divided by the reduced brightness, the voltage with which the beam arrives at the sample, times 1 over the half opening angle of the beam. So note now that we see that indeed, as we've seen before, the image probe contribution depends on the opening angle of the beam as 1 over alpha. We've also seen that from doing the magnification relations. We can also plug in the magnification relations here to relate dV to dm and alpha s to alpha m, where we could see that if the voltage remains the same, these expressions would be exactly the same. But we also see that we have the probe current in here. So the important thing to realize now here is that if we change the opening angle of the beam, we influence the image contribution both by the opening angle and the current in the beam. But if we would just change the current in the beam, keeping the opening angle the same, the image size still increases because of the increase of the probe current. We also see that the reduced brightness is in here, which again, as we said before, is a source characteristic. So it's a given property for a specific source.